Looking at the new automated filter assembly line at the Racor filter plant in Modesto, California. Racor is a division of the Parker-Hannifin Corporation. Our new assembly line has a production capacity of up to 100 assemblies per hour under its present configuration. This system, currently being used to produce diesel fuel filter water separators under stringent statistical process control specifications for Navistar, has increased our capacity to produce high-quality filters more efficiently and with greater precision than ever before. The production capabilities and ergonomic values of this new line far surpass our previous assembly systems, leading Racor into a new and technically advanced phase of production. One of our new assembly line consists of an automated conveyor system built by Weldon Corporation of Buchanan, Michigan. It was designed by Weldon and Racor engineers. At Station 1, the main assembly casting, with some of the part attachments hand-tightened, is clamped down in a precise position on a pallet, with clearances determined to a few thousandths of an inch. The unit then moves to the next operating station in response to the computer program which controls the movement of the pallets. At the next station, an automated tightening system built by Case Automation Incorporated in Orange, California, spins on subunits to a specified torque. During the tightening cycle, an air jet blows contaminants from the fuel passageways, and a vacuum hose removes them from the unit. Units move to the next station, where the filter element assembly is installed. The position of the water probe is checked, and if necessary, the operator turns the bowl assembly to achieve the proper orientation of the probe inside the unit. The integrity of each nearly finished unit is then tested by an automated system designed for Racor by Cosmo Instruments of Farmington Hills, Michigan. Each unit undergoes a test for potential leaks at 2 air pressures, using a pressure decay system that is reference chamber compensated to ensure reliability. Units that pass the leak tests move on to the last station, where they are removed from the pallets and dust covers are added to all open ports. Finally, the units are given protective paint covers and packed for shipping. Rejected units that have failed the leak tests are automatically routed to a rework station. At the rework station, units are examined and rebuilt, after which they are again clamped on pallets and re-enter the test cycle. to appreciate the advantages offered by this automated system, let's compare it to our old line where the same Navistar filter was previously assembled. Our manual assembly line required as many as 9 people to operate at peak production. Physical setup was such that materials were delivered to an outside aisle, requiring second handling and non-productive time as the operators walked to retrieve materials for assembly. On the new line, all materials are delivered to within arm's reach of the operators. Each unit had to be picked up, clamped down, and then unclamped at each station. The nearly finished units were tested for leaks in a water bath. The operator had to subjectively evaluate both the size and the number of air bubbles coming from the submerged unit. This visual inspection method had the potential for operator error in either passing faulty units or rejecting good ones. In addition, the exposure of each unit to water could lead to the possibility of corrosion if the unprotected surfaces were not dried off completely. Our automated system operates with a greater than 50% labor reduction, measured in operator time per unit. In addition, the new system is substantially cleaner. Parts bins and equipment are covered between production runs. Materials are delivered to the line in bags to reduce contamination. However, the most important advantages of the new system are precision and flexibility that are inherent in the automated assembly process. The brain of the system, located in this cabinet, consists of an Allen Bradley programmable logic controller. It directs all the pallets to their appropriate stations and controls the timing of each operation. Torque specifications are preset on the automatic wrenches. The operator checks the torque at regular intervals to ensure the specifications are being met. The automated test chamber can detect leak rates down to 1/100th of a cubic centimeter per minute, permitting very strict and consistent test standards. In the near future, the test results on each unit will be permanently recorded on an attached printer and used for SPC data analysis. In addition, this automated system relies on high-quality Parker and Schrader bellows pneumatic fittings and pneumatic cylinders. Control valves. Gauges. And hoses. Which assure the reliability of the system and the consistent quality of the finished products. As for flexibility, the system can be programmed to handle up to 4 different products without any structural changes in the assembly line. 1 high volume or primary product and 1 low volume or secondary product, which would begin assembly here and can be produced at the same time. By combining new technology with our traditional attitude of ensuring customer satisfaction, Racor and Parker Hannifin are names you can trust to meet your future filter production challenges.